Hello, folks. How's everybody doing out there? And yeah, welcome. Welcome to Lisbon. Welcome to the first Azure Dev Summit. Welcome to the first of 3 talks that I'm giving over the next 3 days, because I don't know how to say no to things. People say, can you do a talk? I'm like, yeah, all right. And yeah, it's the first time I've ever spoken in an inflatable square igloo before, so that's nice. My name is Beattie. I write code, I write music. I've been a developer of one kind of another for pretty much my entire life. I run a training company called Versatile, which I set up at the start of 2020 so I could do lots of traveling, because I am terrible at making business plans that take the real world into account. I'm a Microsoft MVP. Thank you, Microsoft, for that. I run the London.NET user group in London, where I live. And you might have heard of the most successful project that I have ever done in my life was a project that started out in a bar as a joke. And then the joke got out of hand, and the joke turned into a programming language called Rockstar, where you can write software that looks like the lyrics to heavy metal songs. And yeah, it is still a joke, but now it's a joke with a reference implementation, and the joke runs on WebAssembly, which is fun. So if any of you fancy becoming a Rockstar programmer, you can check that out at codewithrockstar.com. Now, the title of this talk comes from, well, it's a variation on a famous quote that you probably know, which is from the movie Apollo 13. Which is a dramatization of the story of the Apollo 13 mission that was supposed to land on the moon, but it didn't, because there was an explosion in one of their liquid oxygen tanks, and it crippled the spacecraft, and NASA had to figure out how to bring the astronauts home, and then many years later it was made into a movie, and it's a movie that's been hailed for its historical accuracy. And at some point in that movie, this is Ed Harris playing Gene Kranz, who's the NASA mission controller, comes out with this fantastic quote, "Failure is not an option." Now, he didn't say that. Well, he did say that, but he didn't say it at the time. He said that about 30 years later when the real Gene Kranz was doing interviews with the people who wrote the movie. And they were, asking him of his recollections of what it was like. And he said to them one day, we realized then that failure was not an option. And they went, that's it. That's the quote. That's fantastic. Can we use that on all our movie posters? And he liked it so much that he then borrowed his own quote back from them and made it the title of his autobiography, Failure is Not an Option. Now, let's just think about that for a second. By the time this happens in the timeline of the movie and the real mission at that point in the mission, they've had a crew member drop out because they got measles, so they had to have a change of crew. They had an engine shut down on launch. The Saturn V launch vehicle, this thing here, it's called that because it's got 5 engines, and it can get to the moon with 4 of them, and one of them just cut out on liftoff, and they went, yeah, it's all right. We'll just burn the other engines a little while longer. That'll be absolutely fine. And the Apollo program, the whole initiative to land human beings on the moon, that had seen, hundreds of setbacks, from trivial mechanical failures through to a tragedy, a launch pad fire that killed 3 astronauts. So when you talk about, failure is not an option, Saturn V was engineered to 99.9% reliability. And it had 6 million moving parts. So a normal mission, a successful mission, was one where only 6,000 things went wrong. So clearly, failure was very much an option, because at every level of the program, they were engineering tolerance and backups and plans and failovers and all kinds of things. And one of the people who I don't think gets nearly enough credit for inspiring that kind of engineering was this lady. This is Margaret Hamilton. She led the software development team that wrote the guidance software, which took Apollo to the moon, landed it, and brought them back safely. And there is a fantastic quote from Margaret Hamilton about this. She says, you begin to think in terms of modeling all these things as one system. Part is realized as software, part is what she called peopleware, part of it is hardware. She was adamant from the beginning, you are not going to build a rocket ship and then tell me to install my software on it and then go to the moon. We are going to be involved in this thing. We are one system. Life support, that is another system. Navigation, propulsion, these are all systems. They all need to work together. We all need to talk to each other because we are delivering the same goal. We are working towards the same outcome. And of course, that outcome is what I think is the greatest user story in history, which was JFK's speech at Rice University in 1962. This nation will commit itself to landing a man on the moon and returning him safely to the Earth. And they did. Men walk on moon. There it is. There's the headline, July 21st, 1969. Now, how many of you folks work on teams where you have like product stories and user stories and you move them across the board as you're delivering? Is the story done when the news headlines happen? No, because everyone forgets about return them safely to the Earth. Because they're like, hey, they landed on the moon, we got the footprints, they planted the flag, yay, finished. It's like, no, we're not finished. Come on, get back, take another look at the requirements. The system says, land them on the moon, return them safely to the Earth. It wasn't actually done. And then safely to the Earth, well, when they landed, when the astronauts got back 4 days after this, they went into quarantine for a month in case they'd caught moon diseases. So maybe they weren't safe until 30 days later. You know, when was the story actually done? When did the system deliver the outcome that the people wanted it to deliver? Now, Apollo 12, a couple of months later, that became the second successful human mission that landed on the moon. It very nearly didn't. Apollo 12 was struck by lightning twice during launch. Now, I want you to imagine for 1 second that me and two of you, well, actually astronauts are maybe a little thinner than I am, but we got 3 people in a little capsule the size of a tiny car, and you're sat on top of 2 million liters of the most explosive rocket fuel we've been able to come up with. And there is a massive loud bang, everything lights up, then all of the instruments go dark, all the lights go out, everything completely shuts down. First thing you're thinking is, well, we're not dead, so that's something. But, you know, they have no precedent. Well, it's not entirely fair to say they had no precedent for this. What happens is everyone can see that it's been struck by lightning. They're like, okay, what's happened? What's the problem? And the symptoms they're getting are everything has gone completely dark. They still have radio. And this guy called John Aaron, and he was the Electrical Environment and Consumables Manager, a system called ECOM, on the Apollo 12 mission. And he was one of the people who had helped to design the thing, systems thinking. He was involved in designing it, installing it, and then in the control room, in the mission control, when this was actually going on. And he had an idea. He's like, well, if all the lights have gone out, then that's probably not a failure of any of the important systems. It's probably a failure of the instrument panel. They lost power to the dashboard. That's the only thing that's wrong. Now, you go back to that famous photograph of Margaret Hamilton. The thing up above her head there is the main control board on the Apollo 11 command capsule. And if you look at that very closely, right down in the corner down here, there is a little switch called SCE. And it has 2 settings. It has normal and it has auxiliary. SCE is signal conditioning equipment. And they put the switch in because they're like, well, if something knocks out all of the power to the instruments, we'd probably better have a backup. And so he comes on the radio, and his ECOM here recommends setting SCE from norm to aux. One of the crew, who knows where the switch is, they reach up, they flick the thing, lights come back on, and they I guess they must have been looking at each other like, is this okay? Do we go to the moon now? And so they do a couple of orbits around the Earth, and they're like, yeah, it looks all right, and off they go. And they become the second crew to land on the moon. Now, even if that thing hadn't worked, there was a thing called the Launch Escape System, LES, which was basically an ejector seat for the Saturn vehicle. So if the worst came to the worst, they could flick a switch, this thing would blast them off the top of the rocket, launch them clear. In theory, they would parachute back down safely to Earth. They wouldn't go to the moon, but they'd be okay. This was never used. The Apollo is remarkable. Saturn V is being remarkable for about being the only rocket in history that never exploded. Every single one of them that they built made it into space, and the bits that were supposed to come back, most of them came back. And you know, the program as a whole, even though the Apollo 13, the story that's dramatized there, was about a catastrophic failure of a single component, as a system, the whole thing was unbelievably successful. And the full context of that quote is this: we've never lost an American in space. We're sure as hell not going to lose one on my watch. Failure is not an option. Gene Kranz is not talking about we can't afford to have a fuel tank fail. We can't afford to have an engine fail. He's saying we can't afford to have the system fail. The American manned spaceflight program is on my watch, and it's not going wrong while I'm looking after it. Now, they went back to the moon 4 more times after that, Apollo 14, 15, 16, 17. But by then, everyone was getting bored of it, because human beings are fickle. Like, the first time you go to the moon, amazing. 4 times later, you're like, no, not really interested in the moon anymore. But NASA was working on something else, something that was new and exciting and was going to invigorate enthusiasm about spaceflight for a new generation. the space transportation system, the thing that we all call the space shuttle, which is actually 3 different systems all working together as one system. Because if you look at an actual photograph of the thing, you've got the big bit in the middle with the wings that we all call the space shuttle, and you've got the big orange bit underneath, that is the external fuel tank, and you've got these 2 things down the side, which are the solid rocket boosters. Now, the space shuttle, the space transportation system, that flew with a whole bunch of new ideas. They had computers on board for the first time. It was fly-by-wire. There was no mechanical connection between the control surfaces and the rest of the spacecraft. It also flew with a bunch of stuff that had flown on Apollo half a dozen times, and it seemed fine. So, hey, you know, if it's not broken, why fix it? But they realized that with fly-by-wire, a computer glitch could be really, really bad at the point where the computer is basically flying the space shuttle during launch or during re-entry, the most dangerous parts of the mission. Now, when it comes to reliability, computer systems, they fail in 3 different ways. There is the easy one, which is where you say, do this, and the computer says, no, error, doesn't work, not found, invalid exception. Something goes wrong immediately, and you know that it didn't work, and you can punch the error message into ChatGPT or whatever we do these days, and it'll probably tell you what went wrong with it. Sometimes you say, hey, computer, do this. Computer. And you're like, oh. And eventually, some part of that system is going to go, nah, it's not coming back. It says here I should wait 20 seconds for a result from that operation. I gave it 20 seconds, no result. But then sometimes, you're trying to load the news on your laptop, and you don't get a 404 and you don't get a timeout. You get something weird. And it looks like it's the right kind of result. Like maybe it's the right data type, or maybe it's within range, but there is something anomalous about this thing. And you look at it, and you're like, well, is this valid? Is this correct? Or is this an error? So what you do is you validate it. You're looking at the news on your laptop. It comes up with something really weird. You're like, that's really weird. I don't think SpongeBob invaded Luxembourg. So you get your phone out of your pocket, and you check the same website. You're like, OK, well, that's bad. Maybe you go and check it on your iPad as well. You're like, OK, something is wrong with my laptop. The kids have messed with it, or I got a virus or malware or DNS, or something's gone wrong. But you can eliminate the laptop now because you know it's failing. There's a problem with it. But the other 2, you have 2 sources of truth, and they agree, so that's reliable. Or you just get nonsense everywhere. And you're like, this is a catastrophic failure of something. The content management system behind this website has fallen apart. DNS has fallen over. I've got malware on my Wi-Fi router, maybe, that's interfering with all of the data. And so at that point, you fail over to a completely different mechanism, which is as far separate from all the others as possible, to see if you can actually get something authoritative that tells you what's going on. The space shuttle flew with a bunch of these things on board. It initially flew with 6 of them. Now, this is an IBM AP101. It's basically an IBM mainframe in a box about this big. You can see the handles on the front there to install and remove the thing. And the way that these things were built was there were 4 of them running identical software, identical storage, identical memory that were all connected to a single clock chip. So not only were they running the same code, replicated 4 times, they were running the same code with the same instruction counter. So they should always do exactly the same thing. So these would control the shuttle guidance, avionics, and navigation. If at any point one of them gives you a different answer, you could reasonably conclude that that one unit, there was a defect in the hardware. There's something wrong with that AP101, and so you can take it out of the loop. You've still got 3. 3 is good. If you get down to 3 and one of them starts giving you a defect, well, now you can trust the other 2. But the NASA launch control criteria said, well, if you get down to 3, actually you need to come straight home. Because you get down to 3, and then we lose another one, and then we get a defect. Now we don't know which one to trust. We do not know which one of these machines is telling the truth anymore, so yeah, don't do that. If all 4 of them suddenly started giving wildly differing information, at that point, they would fail over to the 5th one. Now, the 5th one, what they did is they took the same spec, and they gave it to a completely different contractor and said, write us this software. Because their risk analysis showed that the likelihood of 2 different systems produced by different contractors having the same bug in the same place at the same point in the mission was low enough that they were prepared to accept that risk. And so if all 4 of the primaries started showing, they're like, okay, we found a catastrophic bug in the main system, but there probably isn't a bug in the failover system at exactly the same point. And that would give them enough. It couldn't fly the whole mission, but it was enough that they could spin the thing around and bring it home. Now, they initially flew with a sixth one, and the sixth one wasn't loaded with any software. They put it on board, and the idea was that if they lost one of the others, there was a contingency plan where the astronauts could put this in, they could power it up, they could duplicate the software onto it, hook it up to the timing chip, and away they go. They never did that. They never had to, because the system as engineered never failed badly enough. They required this. And so after a couple of missions, people in Congress start asking questions about, why are we spending all this money on rocket fuel to take a spare computer into space every time when we don't need the spare? And they stopped carrying it. Now, human beings, our attitude to risk is highly, highly illogical. Did any of you folks get here to Lisbon by plane? Any of you folks fly in? I know I did, yeah. Because you fly in, and some folks don't like flying. Some people are very, very nervous flyers. They're like, I'm in a metal tube in the sky, and we are all going to die. And this is not supposed to happen, and I hate it. And then they land, and they're like, we didn't die. I lived. I survived the flight. And you get out of the airport, and you get in a taxi. You know how much more likely you are to die in a taxi than you are to die in an airplane? Like, taxis are way more... But the difference is, for us, driving around, traveling in a car, that's just an everyday experience. It's mundane. When we build a mental picture of what it's like to be in a car, we're like, well, a car is a car. I drive my car every day. For a lot of people, flying is not an everyday experience, and so when they think, oh, what are aeroplanes like, their brain goes straight for the news headlines and the things they've seen on TV and YouTube and in the paper about plane crashes and high winds and all the kind of things that grab headlines. Because when an airplane just takes off and lands and everyone, has their gin and tonic, that's not news. Nobody cares. That's not a good story. And so we remember the stories because it's an unfamiliar experience. Now, this idea of familiarity, and we tend to, when things are familiar to us, we tend to minimize the risk associated with them. It's true of software as well. You ever install an update on your laptop right before a really big demonstration or like a sales meeting? No. You wouldn't do that, because it introduces unfamiliarity, and new things, novel things, are risky because you don't know yet if they're going to work. Now, this is not just hearsay. This is an observed engineering phenomenon which is known as a bathtub curve, which is when you have a system, a piece of software, a piece of hardware, mechanical engineering, whatever. The failures over time look like this. Systems that are early in their life cycle, they tend to fail because of problems we haven't found yet. And then they just kind of rattle along for a good long time where everything kind of works and don't mess with it. And then eventually the failure right now in mechanical systems, this is because pieces start to wear out. I got a car that's 20 years old, and it's time to get rid of that car because things just keep going wrong because none of the bits were built to last much longer than that. In software, things don't wear out. What we get is we get early life cycle defects. Now, if you ship your product to your customer while it's at the top of this curve, the customers find all the bugs for you, and this is how you get Windows Vista. And then you take the same code base, and you wait till you found all the bugs, and then you ship it again with a different number on it, and the same product becomes infinitely better because all the bugs got found now, and you haven't done anything too dramatic with it. Then software just kind of ticks along. Now, software doesn't wear out. We have security vulnerabilities and stuff goes out of support, but it doesn't fail the way mechanical systems fail over time. What tends to happen with software is that at some point we stop maintaining it because the new system is coming. So we've got our early life cycle defects are the bugs we haven't found yet. Random defects are just like, the failing of a network card, bad memory, whatever, dodgy network, DNS. And then the late life cycle defects are the ones that build up and up and up until finally we decide we've got to switch the thing off. Now, like I said in software, hey, new system, stay alert. We don't know where all the bugs are. Relax, everything is fine, and then, the replacement is coming soon. Now, a real-world example of this replacement coming soon thing is Berlin-Brandenburg Airport. This opened a couple of years ago. It opened something like 11 years late because it was supposed to open in, I think, about 2008 or something, but there was a problem, and there was another problem, and there was another problem, there was another problem, which meant that for about 15 years, if you wanted to fly to the capital of Germany, one of the most significant cultural and political cities in the world, you had to fly into Berlin-Tegel Airport, which is a little airport on the outskirts of town that doesn't really work, and it's not on the metro system, so you have to get off the metro and wait outside the lawnmower shop in the rain for the bus that takes you to the airport. And I guarantee, about once a week, somebody would have said, we should just extend the metro to Tegel, and someone said, no, Brandenburg is opening soon. We're not going to invest in the old system. The new one is coming. Have you worked on software projects that are like this? Like, oh, well, we're putting this one in maintenance mode now because all of our engineering effort is going on the new system, the big rewrite system, which will launch by the end of the year. And of course, it never does. And it takes years and years and years. And so you end up with an old system that's falling apart, but you still got to live with it, and a new system that's amazing and shiny, but it doesn't work, and half of it doesn't exist yet. The space shuttle never suffered from a catastrophic software failure, but this attitude of familiarity informing people's decisions about risk, that was going to have catastrophic consequences, because there was a set of things called the Space Shuttle Launch Commit Criteria. Can't launch the shuttle if the wind is going more than like 40 kilometers an hour. You can't launch the shuttle if it's too hot. You can't launch the shuttle if there's more than a certain amount of rain. But they launched the shuttle from Florida. And, you know, think about Florida, right? Palm trees and oranges, and it's really hot. They didn't think about cold in the launch commit criteria, so they didn't have a threshold. And so what happened, 1984, winter 1984, it was 13 degrees Celsius. And NASA are like, it's a bit cold for Florida. Is it okay to launch the shuttle? And so they go around all the contractors and the suppliers, and they're all like, well, it's not a brilliant idea, but we're not going to stop you because we don't want to get into trouble and we don't want there to be a meeting. So they launched it, and it was fine. And 1985, 10 degrees Celsius. And they go around all the contractors again, hey, and they're like, well, 13 was all right. I guess 10 is probably fine. And then 1986, 6 degrees Celsius outside. Some of you folks might have seen this one on the news when it happened. Challenger. Exploded 75 seconds into launch. Killed all 7 crew members on board. An investigation determined that the explosion was caused by cold weather. There were rubber seals on the external rocket boosters that at low temperatures, they became brittle. And as the spacecraft expanded, the rubber did not expand to fill the gaps properly. Basically leaking explosion, ignited the main fuel tank. Challenger exploded. Now, one of the people who participated in the investigation into why that happened was this guy, Richard Feynman, the Nobel Prize-winning physicist. And his observations did not form part of the official report. They formed an appendix. They published everything he said as a kind of appendix to it, Professor Feynman's observations on the Challenger disaster. And one of the things he said was this: we have found that the certification criteria used in the flight readiness reviews develop a gradually decreasing strictness. The argument, the same risk was flown before without failure, is accepted as an argument for the safety of accepting it again. If any of you has ever had a problem with your car where the seatbelt doesn't work, and so you can't actually do the seatbelt up, and you need to drive it to the shop so they can fix the seatbelt, the first time you drive out on the street in a car with no seatbelt, you're like, I'm going to die. I'm terrified now. And it's amazing how quickly you just relax and be like, well, you know, but you don't need a seatbelt when you drive. You need a seatbelt when you crash. If you're not crashing, the seatbelt doesn't do anything. And so our attitude to risk is informed by the fact that we've been driving for half an hour. We haven't had any crashes at all. And this is the problem. Now, when it comes to engineering systems, one of the astonishing things that has changed over the course of my career is we used to have to build these layers of resiliency into everything we did. You know, seat belts and backups and failovers and little switches that would flip things over to backup engineering. And now we have cloud, which means in a lot of cases, as long as you know what to do, you don't actually need to worry about building it. You just need to know where you left it. It's the equivalent of, imagine we had a building and we're like, well, no, we don't need fire extinguishers in the building because we have Amazon Prime. So if we smell smoke, we can get fire extinguishers delivered within 90 seconds, which is great as long as it works, right? This is kind of modern engineering. I used to have to, we need a spare web server, right? That's going to take 3 weeks. Now I'm like, we need a web server because ours fell over. All right, we can have a new one up in 30 seconds. So it's a whole different attitude to failure-tolerant engineering because it's so much easier to provision new systems, deploy them, and get them up and running. But it also means we have to consider some new points of failure. So if any of you has ever built a high availability, we got a couple of web servers with load balancers, we got a reverse proxy in front of it, so that's running Nginx, and there's a failover reverse proxy, so if that one goes down, it's 20 milliseconds to bring the new one in, and we got active database replication, and you know, the whole thing is absolutely bulletproof, and you've load tested it, and you've done chaos monkey testing where you randomly delete one server, it all stays up. And then one day the whole thing just goes zoom, and absolutely nothing is available. because it turns out it was all being paid for with one MasterCard. And that MasterCard has just reached its limit, and so for your convenience, they have shut down all your services until the billing discrepancy is resolved. And the problem here is that the developers, the engineers, the people who work on systems, MasterCard's not our problem. Somebody else must have taken care of that, right? And so this is a failure of systems thinking. It doesn't occur to us that the finance department could be responsible for downtime. But actually, paying for the stuff you're using is absolutely as important as having connectivity and bandwidth and backups and all that kind of stuff. And so this is another, the systems thinking thing. You've got to think outside of your immediate domain and think, what are the external factors here that could contribute to the things that we are depending on becoming unavailable? And if they do, what do we do? Maybe you get your own credit card out your pocket, and you're like, hey, boss, by the way, the entire company is running on my Visa card right now. Would you like to fix that because I'm about to hit my limit? Now, the stories that make the headlines are the ones where the engineers involved are adamant that there is not going to be a problem because this cannot possibly fail, because it is state-of-the-art. It's an unsinkable ship. We've got bulletproof safety protocols. This is state-of-the-art technology. It's where people get sloppy. People get cocky because they think that nothing's gone wrong and nothing is going to go wrong. Now, in 1999, so Post Office Limited in the United Kingdom is the company that manages all of the high street post offices. And they commissioned a new software system from Fujitsu Horizon. It's from Fujitsu. It's called Horizon. It cost a lot of money because it is a massive government IT rollout system, probably about £1 billion. They started rolling this thing out across post offices, and then there were discrepancies. Branch offices, they would tally the accounts on the computer at the end of the day, and the computer was saying that money was missing. Now, the sub-postmasters, the members of staff working in these offices, were like, there is no money missing, the computer is wrong. The management said, no, the computer can't possibly be wrong, it cost £1 billion. You must be lying to cover up the fact that you have stolen money, pay it back or you'll go to jail. And a lot of them did. People took out bank loans, people mortgaged their houses to get enough money to settle the discrepancies because the post office was saying to them, look, if you don't pay this money back, we are going to prosecute you as criminals and you are going to go to prison for stealing. Now, this eventually got dragged into a high court inquiry about 4 or 5 years ago. And Paula Vanels, who's the chief executive of Post Office Limited, she said this in court. She said, the message the board and I were consistently given by Fujitsu from the highest levels of the company was that while, like any IT system, Horizon was not perfect and it had a limited lifespan, it was fundamentally sound. Now, was not perfect. You're either sending people to jail or you're not. And if you're going to stand up in court and admit that you know the system isn't perfect, maybe you should have thought about that before you started threatening people with criminal prosecution. The High Court judge who was presiding over this hearing went on record as saying their defense amounts in reality to bare assertions and denials that ignore what has actually happened. They're covering their asses because they don't want to lose their bonuses, is what he's saying here, but judges aren't allowed to say that. It amounts to the 21st century equivalent of maintaining that the earth is flat. Now, this rattled on for a long while, kind of nearly 20 years, of these prosecutions and criminal records hanging over innocent people because the management and the companies involved were not prepared to acknowledge that there might have been a problem with the computer. There was finally, they got their criminal convictions cleared a few years ago. The court case overheard it. There was then an act of parliament that said everybody who has criminal charges associated with this, they're all gone. Wipe them all clean. Quash all of those convictions. None of those people are actually criminals. There has been a horrible mistake. And even then, this did not make it into the headlines until last year when a TV show, Mr. Bates versus the Post Office, this thing went out on primetime television. And finally, like the rest of the country woke up and went, oh, holy crap, that's quite bad. Like, people went to jail. Now, some of those people, they had a criminal record hanging over them for 15 years that was then quashed, and now they're free. Some of them didn't live long enough to see that. Some of them died as criminals because somebody was not prepared to admit that the computer that they had approved £1 billion worth of investment on might have problems with it. Now, I've worked help desk. I've dealt with end users. I have had those phone calls from someone going, where are my files? You deleted my files. And you're like, no, we didn't delete your files. We told you to put them in OneDrive, and you didn't put them in OneDrive because you never put them in OneDrive because you're an idiot. But you don't say that. You're like, terribly. So give me a minute. Let me go and check the backups. Well, I'll call you back in 5 minutes. And of course, there are no backups to check. So you go, you have a cup of coffee, and you look out the window, and you think about your life. And then you go and you call them back, and I checked the OneDrive. Maybe next time, try putting them in OneDrive like we talked about, We've done this. But if somebody was going to go to jail, I'd check the damn backups, I would absolutely take responsibility. And that's, again, it's systems thinking, but it's about thinking, what are the consequences if this thing doesn't work? Web page doesn't load? Yeah, probably not a big deal. Somebody gets a criminal record? We'd probably better check what's actually going on here. Now, we tend to make a lot of assumptions about availability and the way systems work. One absolutely classic one is two-factor authentication using SMS messages, because it doesn't occur to most developers that you might be using the internet somewhere where your phone doesn't work. Because you work in a basement, or because you work in a very old building, or because you live in the middle of Wales and your house is in a valley and there's no mobile phone signal, and so you got to log into your online banking, and they say, we've sent you a text message, and you have 5 minutes to go outside, jump in the car, drive to the top of the nearest hill, hold your phone up till it gets on the network, look at the message, maybe take a screenshot of it, drive back down and get it in before the authentication expires, because it hasn't occurred to the developers that this failure model exists. Now, the other thing that developers, in my experience, often forget or underestimate is we don't realize just how inventive end users can be. Because the only reason they're using our stuff in the first place is they got a job to do. They have an outcome. They got a thing they want to accomplish. And end users are infinitely resourceful when it comes to using the tools available to do the thing that they want to do. Many years ago, a friend of mine worked at a big industrial instrumentation company. They made laboratory equipment and microscopes, and the company was so paranoid about industrial espionage that they blocked attachments on email. You couldn't send files in or out of the company network over email. Which is great, except they have field service engineers who are all over the world in hospitals and universities repairing and maintaining this equipment, and they need firmware, they need service updates. And so what happened is the software developers and the field engineers, they got together and they worked out a system. If you needed to give someone a firmware update, you wouldn't email it to them, because if you emailed it to them, you'd get fired. What you'd do is you'd log into a Hotmail mailbox, and you would attach it to a draft, and then log out. And then the field service engineer could log in and download the attachment from the draft. The email never got sent, right? So no one has broken the rules, but they have the code they need, the customer is happy, you got the update out to them, and no rules were broken in the fixing of this microscope. Now, I love these stories about human ingenuity, and you give people some technology that maybe wasn't supposed to do that, but they found a way. And my favorite example of this, I grew up in Africa. I spent my childhood in Zimbabwe, and we would go on family holidays where we'd all get in the back of the car, and we would drive for hours along roads that looked like this. There is nothing there. Drive out into the bush, and just once in a while, there would be a little shack by the side of the road, and it would be red and white painted corrugated tin, and it would say Coca-Cola. Because Coca-Cola's ability to find anywhere that people have money and sell them sugary drinks is astonishing. I have no idea how they do it. I was back in Africa a few years ago. I went out there for my cousin's wedding, and we're driving along the same kinds of roads out in the bush in Zambia. And there are still the little red and white shacks at the side of the road, except they don't say Coca-Cola anymore. They say Vodacom. Because cellular networking has been an absolute game changer for large parts of the continent of Africa. Now, go back 25 years, around 2000, you go to Nairobi, which is a capital city in Kenya, and downtown Nairobi is bustling. It's got cinemas and banks and shops and all this kind of stuff. There are internet cafes. There's a couple of little startups. There are people working on the web and email and all these kinds of things. But if you drive an hour in any direction, you'll find people who have never made a telephone call. People who are like their entire lives has been lived that far off what we would consider to be the grid. Now, the problem with wiring somewhere like Africa, if you want to put in cable and make money out of it, you need three things. One is you need population density. You've got to have a lot of people who want to be able to use that piece of wire so you can make your money back. Two, those people have got to have money. And 3, you need a sufficiently stable government that if you go and put all the stuff in and contracts are drawn up and provision and supply and all this kind of stuff, there are courts that are going to enforce that. Africa, unfortunately, had none of these things. Very, very sparsely populated. So if you wanted to run a telephone cable from the capital out to one of the surrounding towns, you're talking about 100 kilometers of cable. When you get there, there's only 50 people, and none of them have any money, so it's not like they're doing cell phone service. And then you come back the next day, and somebody has dug a hole, and they've stolen your cable, because copper is worth a lot of money on the black market in large parts of sub-equatorial Africa. So when cellular comes along, they're like, okay, this changes everything. Because one, line of sight is fantastic in big, flat, wide open spaces. The weather tends to be very dry. You get excellent signal. You put up one tower, you can reach 400 square kilometers. You then have the problem, well, they're probably not going to steal your cable, but you then have the problem of how are we going to get, what's the customer base for this? Who are the people who are going to use this? Now, when Vodacom first rolled out cellular networking in Kenya, what they discovered is there was a lot of places where the customer would be one person in a village who had a phone, and that phone was their business. Because if you wanted to make a telephone call, you would go into the town and you would go and see them, and you'd give them cash, and they'd let you make a call. And they would send and receive text messages on your behalf, and this was the infrastructure for them running their digital communications business in Africa around the turn of the millennium. Now, because most people were what's called unbanked, they didn't have bank accounts, they didn't have lines of credit, so almost all of the handsets were prepaid, which meant to top them up, you needed to buy top-up cards. Now, one of the big challenges with this kind of economy is a lot of people would leave the village where they grew up and they'd go and work in the city and make money, and they wanted to send money home to their families. And if you wanted to get money from Nairobi out to one of the surrounding villages, you kind of had a choice, because they don't have a bank account or the other, and you need to get them cash. So you could take a couple of days off work, and you could go and visit mum and give her the money and then come back. But yeah, that gets expensive. Or you put it in an envelope, and you find a trustworthy-looking bus driver who's going in the same direction, or you give it to a friend, and maybe most of that money makes it to the other end. And then somebody had an idea. They figured out that they could walk into a Safaricom store in downtown Nairobi, and they could buy like a 10,000 shilling top-up card, and they could phone the phone guy in mum's village, and they could read the number off the back, and then that guy gets 10,000 shillings worth of phone top-up, and the next day mum comes in for groceries, and she gets 9,000 shillings because the guy's got to make a percentage, right? So somebody has just invented wireless money transfer using a cell phone and a scratch card in Kenya 20 years ago, in a country where most people don't have an internet connection or a bank account. Now, this gets off to a good start. What they figured out relatively shortly after this was they launched a thing called Friends and Family, which lets you transfer credit to your friends. Immediately, everybody was everybody else's friend, because it meant they could transfer airtime credit. And so an entire kind of economy sprung up around people using phones to transfer credit and top-up time. Somebody could, they'd go to a market, and they would, instead of paying with cash, they could pay someone by sending them a message, sending them 1,000 shillings worth of credit. That person tops their phone up. They can use that. They can go and use that to pay the doctor. The doctor then uses the credit to pay the guy who's going to fix their bicycle. A bicycle repair person uses it to buy a bag of flour. We have this entire circular economy. Now, this is not wireless banking, because there's no banks. There's no accounts backing up any of this stuff. Literally, each one of those phone handsets is effectively a digital wallet containing wireless currency. Now, there are two ways you can look at this, because somebody at Vodacom and Safaricom, the big network operators, probably looked at this scenario and went, this is a disaster. These people aren't making phone calls. All they're ever doing is sending each other credit. Nobody is actually buying the service we provided them. But that's not what they did. They looked at it, they looked at the usage patterns, and they went, we think there is an opportunity here. We think there is a chance to do something really interesting. And so they took the patterns that had been created by the end users, and they turned that into a product called M-Pesa. M is mobile, Pesa is the Swahili word for money. Now, M-Pesa basically took what people were already doing, and it backed it up with assurances around your deposits. They rolled out things like you'd have an M-Pesa savings account, so you could transfer money into that. They would pay interest on the savings. Within a short while, M-Pesa had transformed the economy in Kenya. It's quite amazing to think about it. It was a success story for the entire country. It was a path out of poverty for something like 250,000 households. Now, the weird thing about it is it never worked anywhere else. They tried rolling out M-Pesa in different places around the world. Kenya got it at Kenya and Tanzania. They got it at the exact right moment when there were just enough phones and things like, credit cards and internet banking, they weren't ready yet. And so they got into that market at the right point and established a foothold there that still exists today. If you go to a gig in Nairobi now, it's quite common. You can buy merchandise there using M-Pesa. It's just like a ubiquitous system. They tried rolling it out in Romania, but by that point, Romania already had Visa and MasterCard, no big deal. They rolled it out in Afghanistan for during the American occupation there. They tried to use M-Pesa as a pilot system to pay the Afghanistani police their wages with M-Pesa, and they discovered that most of them didn't exist. And what had happened was that the sergeants were making up police officers and putting them on the payroll because they'd get a bag of cash every week to pay them. And when it went digital, they discovered they didn't have anything like as many police as they thought they did. But even there, it kind of rolled out as a pilot scheme for a little while. But yeah, Kenya and Tanzania, M-Pesa is still there because end users did something that to a certain kind of engineer looks like they're holding it wrong. It's like, that's not how you're supposed to use the system. But the developers behind it, they looked at what the end users were actually doing and went, no, this is not failure, this is opportunity. Let's work with it. So let's recap. Backups, failovers, anticipate things that, what happens if you get struck by lightning? And the important thing about these is not just that you've got them built in, it's that you have the people and the resources to be able to deploy them at the point where it matters. There would have been no point having this switch on Apollo if John Aaron had not been in the room at that moment and been able to suggest, hey, try flicking this switch from here to there, lights come back on, hey, everybody, let's go to the moon. You've got three different kinds of failures you've got to think about. You've got the immediate, there is an error message, this did not work. You've got the nothing comes back, and eventually you have to make the call, request timed out. How long do you wait? We don't know. That's one of the things you need to understand about the system you're building. Do we get a response back in a millisecond, 10, 100? There's a space probe. The Voyager 1 space probe is now out there. It takes nearly 24 hours for us to send a signal to that and get back. So if you're on a 30-second timeout, you think the spacecraft is dead. But no, it's still there. It's just it takes nearly a day to get a ping to it and back again. The single point of failure might be something that is not up to you and your team. It might not be software. It might be finance. It might be infrastructure. It might be legal. It might be the political system in the country where you are deploying your data centers could change. Something that a lot of people are starting to think about at the moment. Think about, it's not your problem to solve it necessarily, but be aware of those things and think, well, do we have a workaround? Is there anything we could do if that thing happens? And never, ever underestimate the ingenuity of end users. They got stuff to do, and you give them a tool, and even if the tool does not solve their problem, they are probably going to figure out a way of using it and a way of deploying it, which means they get to do the thing that they want to do, and they get to go home at the end of the day. So folks, thank you so much for listening. We have a few minutes for questions. Do we have questions? Now, there is a QR code on here. I used to do, yay, follow me on Facebook. Yay, follow me on Twitter. No, I'm on Mastodon. No, I'm on Blue Sky. No, screw it. Social media has been a total disaster. If you want to follow me, I have a mailing list. It uses email, like it worked in the 1980s, and I send mail once in a while about where I'm going and what I'm doing and things I think are interesting. So if any of you folks enjoyed that and you want to keep up with what's going on, join that one. I'll leave that up there for a second. Are there any questions, folks? We have the silence of enlightenment. Even the crickets have stopped. You hear the crickets earlier? Yeah, the crickets weren't in the building yesterday. The crickets got in the night. All right. Folks, thank you so much for coming along. Enjoy the rest of the summit. I'm around. I got another 2 talks coming up on Wednesday. We got a party happening over at the Myriad Hotel tomorrow night, so come along to that. It'd be great to see some of you there. If you're around, do you have any questions, come and say hello. I have some stickers to give away as well if anyone is looking for a little space on your laptop that needs a little bit of rockstar love on it. Thank you so much. Take it easy.